All the girls get down. Get up.
Okay, so now let's introduce the idea of graphing functions, okay? Graphing functions. Alrighty. So, how do you graph a function? So the first thing is, we usually have two axes, okay? And each one is called an axis, okay? So let's say this is x and this is y, because the independent variable, it goes along the horizontal line here, and the dependent variable is the vertical axis, okay? Just as, here's another example, if we were to have height depends on age kind of thing, we would have h up here and a on the side, because this is our independent variable along the horizontal axis, and this is our dependent variable on the vertical axis. Okay, so that's how you set it up. And then it depends on what you're going to do with it, but and what your function looks like. But let's say a pretty simple function is a line. Okay, so I'll just draw that in here. Okay, so let's say this is our function. This represents y is equal to f of x. That's how we denote it here. Okay, so basically what goes on when we graph functions is that where you are on the x-axis, meaning your x positioning, let me label these here, okay? So just to show you guys what's going on. So let's say our x is equal to 2. So that would be right in here, okay? When x is equal to 2, we'd be on this line kind of thing. We'd be looking here on this kind of like invisible / shaded line. And then we see, okay, so where does our function take x equals 2? When we input 2, then where does our function go? And the answer for this case would be y equals 2. Okay, so that would be like an input and an output pair that we could have, 2 and 2, where x equals 2, then our y is equal to 2 as well. Okay, so that's what our function kind of represents here. So basically, where you are on the x or the independent axis, on the independent variable axis, determines how high up or down you go in line with that. Okay, we'll work with this later on like graphing functions and everything. Okay, so an important thing to realize first of all to determine is whether something is a function or not when you look at its graph, okay? And what we're going to do for this is use the vertical line test. Vertical line test, okay? So let's see an example of this. Let's say we have some graph, x and y, okay? And it looks like this. Something like that, okay? Something funny. Alright, so what we do for the vertical line test, let's think about this. So x represents our input, right? So I'll just write little input here. And y represents our output after the function does its thing, right? So essentially what our function should do, if it is a function or not, okay, what a function should do is take each x value, each input, and kind of bring it to only one output. Alright, so what we do is the vertical line test, which is basically you just, well, if you're working with paper and everything, you would put your pencil on, like, straight up and down, vertically, okay, you'd hold it vertically like this, and here in this case, I'm just going to draw lines for us, okay, and we just draw vertical lines, and make sure that each one of those vertical lines touches only one point on our graph, okay, so let's look at this. So we crossed here, we crossed this one here, this one here, this one here. Alright, so it looks good. It's only each vertical line is only touching once on the graph, which makes sense because each vertical line represents one input. Okay, so for example, let's say this one here, this vertical line represents x is equal to 1. That means whenever we input a 1 into our function, into our alleged function that is, we're kind of questioning whether it is a function right now, but anyways, whenever you input 1 into this thing, then it should only spit out one output, and that output happens to be right here, let's say like -1 or something, okay? So the important thing is that your vertical lines, all the ones that you draw or use with your pencil, they only cross the graph once, okay? So this one is, yes, this is a function, this one here. Alright, so let's show a counterexample now. Let's say here's our x and here's our y. Alright, and let's say we have some function, or some graph, that is, not function, because this might not be a function, and it looks like this, okay? It's kind of like a potato. Okay, so let's try the vertical line test on this guy. So, here, we draw our lines, okay, that's fine, except for, okay, so another thing to note is that the vertical line test, we're going to make sure, let me just write it down here in words so you guys can see. So make sure each vertical line you draw, okay, each vertical line crosses the graph, or your graph, at most one time. Okay, so this means it could never cross. That's fine. Like these ones here that I was drawing, that's okay. It just happens to be that for any x that you plug in, then our function doesn't do anything. It doesn't go anywhere. Okay, those aren't even inputs into our function. Anyways, but then when we get to this point, let me try to draw a vertical line here. It does cross once right here. Okay, but then when we continue going to the right, see how here now we're running into our vertical lines are crossing our graph 2 times. Okay, so for example, like this one here, it crossed here and here. So for like our x equals 1, this graphically, this means that when we put in an input of 1, we got, I don't know, what is this, like -2 and a +2, which that's weird because our function should only output one thing. So this means that this is not the graph of a function, so not a function. Okay? Alrighty, so now we're moving on to the next step. So if something, a graph we could say, if something passes the vertical line test, I'm just going to summarize a little bit here, then it's a function, which is good, okay? Then it's a function. Okay, period. And then we ask, is this function, is it 1-to-1? Is it 1-to-1 function? Okay, so first of all, it has to pass the whole vertical line test, and we have to determine whether it is a function or not. Okay, because if it isn't a function, it can't be a 1-to-1 function either. Okay, but if it gets past that first threshold, then we can ask, is it 1-to-1? Which is, right now you're probably asking, what is a 1-to-1? So let me define it for us. So a 1-to-1 function is the following. 1-to-1 function means that for each input that we put in, there's only one output. I can't spell. Okay, output. There we go. And the important and, for each output, I'm basically going to say vice versa, but in the long drawn out way. For each output, there's only one input. Only one input. I'll put an exclamation mark there because we're just so excited about this. So, this might look a little bit trivial because it's like, okay, we already defined that it's, if we're trying to examine whether it's 1-to-1 or not, we already know it's a function if it passed the vertical line test, right? But then it's like, so it should, for each input, there should be only one output, and it should just work the same way around, right? Like, it should work the opposite way. But that's not necessarily true. So, let's take a look at a table that I showed you guys earlier. We tried this one out. So, x, y, right? Independent variable, dependent variable. Let's say we had -1, 1, 0, 5, and 1, 1, okay? So let's check if this is a function. We already said it is because each input only goes to one unique output, right? However, so the first thing is, yes, this is a function, okay? So this is a function. All right, so it passed the vertical line test if we were to graph these, basically. But now we have to check if it's 1-to-1. And in order to do that, we kind of just look the other way around, okay? So let's say this is our output, right? Now we're in the output line. And then we just look back to see the input. So output, input, output, input. And here is where we reach a discrepancy, right? With this pair here and this pair here, even though we have the same output, we should have the same input, according to the whole 1-to-1 definition. And we don't. It turns out that we don't, because the one that we got as an output, that we got that from plugging in 2 different inputs. So this means this is a function. It is, nonetheless, but it is not 1-to-1. Not 1-to-1. Okay? So essentially, this is just saying that even though we might have a function, which works perfectly in the input to output direction, and for each input we only get one output, that's fine. But in order for it to be 1-to-1, it also has to, for each individual input, it has to output different things for each one. It can't, like, this -1 can't go to 1, and the 1 can't go to 1. That's not allowed for a one-to-one function, okay? That doesn't discount that it is a function of a sort. It's just not one-to-one, okay? So on the next slide, let's examine an example that is one-to-one. All right, so let's say we have our x and y again, okay? And let's say we have something like -1, 1, 0, 5, and 1, 2 this time, okay? So let's check that it's a function, and the answer would be yes, because -1 goes to 1, 0 goes to 5, 1 goes to 2. There are no repeated x's, so we don't have to worry about the same input going to different outputs. So this is a function, okay? And now our question is it one-to-one or not? So function, yes. One-to-one, we're going to check, okay? So now all we have to do is look at the outputs and make sure that none of them, if any of the outputs are the same, that their inputs are exactly the same as well. So in this case, none of our outputs are the same, so we don't have to worry about that. 1 was created by plugging in a -1, 5 was created by plugging in a 0, and 2 was created by plugging in a 1, and nothing matches here, so yes, it is one-to-one based on this table, okay? So for now, we don't really need to know, like, why a function has to be one-to-one or not, but we definitely will use this definition later on. So just store that away, okay? So now the thing is that we have to determine, okay, well, graphically, how do we know if a function is one-to-one or not? So let's see. One-to-one function or not, okay? Or not. Okay, so what we're going to do now is, well, first of all, to determine whether a graph is a function, just a normal function, we use the vertical line test, right? But now, in order to go the second step, then we have to use what's called the horizontal line test. You knew that was coming, right? Anyway, so horizontal line test. So let's look at some examples, okay? So let's say we have a graph that looks like this, which is going to be common, right? You're going to see this all over the place. It's called a parabola. It's like a U shape. Anyways, so let's do the vertical line test first, okay? Let's just determine whether this is a function or not, okay? So if we do the vertical line test, I'm just going to draw very faint lines here, okay? So I just don't mark up the whole screen here. So vertical line test, yeah, this is passing because all of these vertical lines are only touching the graph at one point each time. Okay, so that's good. It passed the vertical line test. This means it is a function of some sort. And now we have to determine whether it's one-to-one or not. So now we use the horizontal line test, which is you operate just exactly the way it sounds. So now we're just going to draw horizontal lines. Okay, I'll draw these a little bit darker. So horizontal lines, and the thing is the same criteria. Now we're just going horizontally. Each line that we draw, each horizontal line, is not allowed to cross our graph more than one time. Okay, and we see that ours here, this graph, when we do draw our horizontal lines, it does cross, well, down here 0 times, but then it here once, and then every point above, every horizontal line we draw that's above this point down here, those cross at two points on our graph. So this one here would not be called, this is not one-to-one. One-to-one. It is not one-to-one, but it is still a function. Okay? All right, now let's look at one more example. Okay, and we'll do both the vertical and the horizontal line tests for it. So let's say it looks something like this. Okay? So here's our x and y, right? So let's do the vertical line test first to determine whether it's a function or not, like a normal function, any kind of function. So the vertical line test looks like it's passing, right? Because it's crossing, each of these vertical lines crosses only once. Okay, we're good. Now let's try the horizontal line test. So now we do our horizontal lines. Okay, and we get, it looks good, right? Because we're crossing only at one point on each of these, or we're only crossing the graph at one point at each of these horizontal lines, okay? So it passes the vertical line test, which means it is a function, and it passes the horizontal line test, which means furthermore that it is one-to-one, okay? So this one is a one-to-one function. Alrighty, now we're going to switch gears a little bit and just say, okay, so what do we do with functions? We know that they represent the relationship between two kinds of quantities, but what do you do with them? So the answer to that would be, what we can do with them is either evaluate them or solve. Okay? So what does evaluate mean? We can do these two things. Okay, so evaluate, we'll start with that one. Evaluate, I'll write a little definition. So if we're given, or just we know for some reason, we already know an input, meaning a value of the independent variable, and we use, well, and use, so given that we know an input and we use a function like an f of x or something like that, use a function to determine the output, okay? Determine the output for that particular input that we know already, okay? So the important thing here is that when we evaluate, we get only one answer. So we get one answer because we're finding that one output for our particular input, okay? Because we have a function, so we only get one answer since this is a function, and one input only leads to one output. So here's a little example, okay? And I'll show you that on the next slide. Okay, so here we have a table. This is our input, and this is our output. And we can tell because they give us that Q is equal to G of N. And it's a little bit funny because mathematicians kind of just throw around letters and like variables and things, and it's like, where did that come from? But basically, our input is our independent variable, right? N is still there. It's inside the parentheses, so we're good with that. But this G just means that Q is equal to some function of N. So Q is the dependent variable, okay? So here in part A, we're going to evaluate G of 3. So here, we know our input. We know our input, or our N in this case, N is equal to 3. Okay? And so what we're tasked to do with here, or the task we are assigned, is basically to find out, okay, so what's the value of our function at that given input? Okay? So G of 3 is the same thing as saying what is our dependent variable, or what is our function value at our input of n equals 3. So what is Q when, we could say, when n equals 3? And our answer, we're just going to look at the table here. So when n equals 3, which is this one here, we're just going to pair it up, okay? And we see that our Q at that time is 7, okay? So that means that our G of 3, which is also Q at the time, is equal to a 7. Alrighty? And that's how you evaluate. So that's pretty much it for that. And now let's go over solving.
My girls get up.